welcome back to this last session today. It is my absolute pleasure to introduce our two speakers. Professor Diana Lange is a professor of history and culture of Central Asia at the Humboldt University in Berlin. Her recent publication includes a monograph, an atlas of the Himalayas by the 19th century Tibetan Lama, A Journey of Discovery, which came out in 2020. An edited collection of essays on maps and colors, a complex relationship, which came out, I want to say last year, but it was actually 2 years ago now, 2024. And these are just two examples of a very, very thorough list of publications on this subject. Our other speaker is Professor Oliver Hahn, also at the Humboldt University in Berlin, works for the Federal Institute for Material Research and Testing, works a lot of preventative conservation, has worked on different scientific testing and research methods on reconstructing the history of manuscripts, projects spanning 3 different continents, looking at manuscript cultures of Europe, Asia, and Africa, and has also recently been working a lot on the recovery of damaged writing, including ink, and as well as colorants and pigments. And these two have been working together for the last few years, and there's some of that research that they will share with us now on colors on maps. So
I entered the world of maps around 16 years ago. My background is Chinese and Tibetan studies. I entered the world of maps while working on the collection of Tibetan maps. I entered the world of colors in 2018. This is when I met Oliver, and I think he entered the world of colors, don't know how many decades ago, because he's from the natural sciences, and he's doing analysis of colorants for years now. That's working. So in between 2018 and 2021, we undertook an in-depth and systematic study on color on maps, and this research was done within the scope of a joint research project entitled Colored Maps, involving 3 different institutions in Hamburg and bringing together 2 very large map collections. One kept in the Hanseatic Business Archive Foundation and the Library of Commerce. These were European maps, and the other collection was the collection of East Asian maps kept at the Museum am Rothenbaum, short MARKK, both in Hamburg. And the third institution involved was the University of Hamburg with the Center for the Study of Manuscript Cultures. In this joint project, we focused on the coloring of hand-colored maps and on the composition of colorants and the color's meaning and purposes. And we focused, as I mentioned, only on hand-colored maps in this project, produced between the 17th and 20th century. And our aim in this research project was to gain insights into knowledge exchange between East Asia and Europe, and a close cooperation between the humanities and the natural sciences. For me, it was the first experience of such a cooperation, was absolutely essential for such a project. And what we want to do today is to share some of our research results with you, with a focus on East Asian maps, namely from China and mainly from Korea, because this is my background. And I must say, we can only scratch on the surface of what we have found out. So color is an important key for a precise or more precise understanding of a map's purpose and a map's use. And moreover, the colorants used for coloring a map are also an important aspect of a map's materiality. So before the introduction of color printing, most East Asian maps were produced as monochrome prints, or they were drawn by hand as manuscript maps. And woodblock printing was the oldest technology for printing maps in East Asia. It was invented in China in around the 8th century, and it quickly spread throughout East Asia, and it remained the dominant technique until the 19th century in the region. I should emphasize that manuscript maps were produced over a long period of time in East Asia in parallel to printed maps, in contrast to Europe. Not much is known about the people who colored the maps by hand. The presumption is that professional map colorists, like in Europe, did not exist in East Asia. So manuscript maps were made by people of various professions who almost certainly colored their maps themselves. And the coloring of printed maps seems to have been executed by different groups of people, such as painters, but also untrained workers, and also by specialized map makers. If you want to take a look at the coloring of maps, if you want to compare the coloring of maps, it makes absolutely sense to investigate in a first step the use of color on a map by examining the so-called color system. That is to take a look what part of the map's content has been colored, has been selected to be colored. And in this context, we different between full coloring, spot coloring, and non-coloring. East Asian maps were widely colored according to a broadly similar system up to the 19th century. So on most maps, the water bodies were fully colored in some way, and the land was left uncolored, although some topographical elements might be picked out in colors, such as, for example, mountains. This is a typical example of such a map, a woodblock print taken from a Korean hand atlas that was hand colored, and you can clearly see the sea is full colored, the rivers are full colored, but the land is more or less left uncolored. We have two more examples, both manuscript maps. On the left hand side you can see a province map from Korea. You can see the same color system. The land is kept uncolored and the sea is fully colored. This is also true for the map on the right hand side, also taken from a Korean hand atlas. Sea full colored, rivers full colored, and the land, with the exception of the mountains, left uncolored. The most common term that you probably also have heard before, used in the connection with map coloring, is color scheme, which refers to the choice of specific colors for different elements of the map. Since traditional East Asian maps share many aesthetic principles with landscape painting, it is not surprising at all to find similar color schemes on maps and on paintings, and that the coloring of topographical features on the maps is related to their naturalistic appearance. So mountains, for example, were colored in green, in bluish tones, but also in brownish tones. On many maps, like on this map, it's an extract of a manuscript map from Korea, altogether 7 meters long, from the mid-19th century. We find similar colors used for the same purposes. So borders, for example, were very often colored in various colors such as green, red, or yellow. Sometimes they were left uncolored. Red was usually used for cities, for military features, related features, but also for roads and for some settlements. Other color schemes provided information about the cultural and administrative units within the various regions, and the classical Chinese 5-element or 5-phases system played an important role in this context, in particular on Korean maps. According to this system, the center is yellow, the east is green or blue, the south is red, the west is white, and the north is black. So traditional colors were associated with a specific cardinal direction. So the colors chosen to distinguish the provinces on Korean maps very often correspond to this scheme. It is a common, though not universal, feature of colored administrative maps made in Korea up to the 19th century. And I have chosen one example here. It's a woodblock printed map, hand-colored, showing all of Korea. On the left-hand side, you see the full map. And on the right-hand side, you can see the area around the capital of nowadays, Seoul. And you can see that the districts that belong to the same province were represented by circles that were colored in the same color. And Seoul, the capital, is the center, so this is why the painter has chosen yellow. If you look further to the south, on the left-hand corner, you see red circles. Red is associated with the south and so on. So color system, color scheme. Now we have the color code. The color code of a map defines the range of colors that were selected to convey specific information about the places and the features represented on the map. So on many East Asian maps, the cultural and administrative function of places were emphasized or coded through the use of geometric outlines such as squares or circles or triangles to mark their location. And the shape might then be filled with color, and by combining these different shapes and colors, the map makers were able to communicate a considerable range of information through their coding of place signs. So here, for example, on the left-hand side, these are extracts of maps I have shown before. Here we have different geometric signs. Here we have different geometric signs plus a coloring inside these so-called cartouches. And on this map of China, we have different geometric frames, triangles, circles, squares. And all of them were used for the different status, or to mark the different status of these places. So this was a short introduction about the purpose of colors on maps and on the outer appearance, but material scientific analysis enables us to find out more about the material composition of colors on maps. And in the case of East Asia, there's considerable evidence that the maps, or that the same colorants that were used for painting were also used for the coloring of maps in that region. And now I hand over to my colleague, Oliver.
Thank you so much, Diana. So why are we doing all these analyses? And this is just to give you an impression about the different instruments or machines which are necessary to do these investigations. As you mentioned, it's very important to know it starts from the materiality. So that means, why are we doing this analysis? First of all, we want to have an idea about the purpose. But what is also very important, and I'm very grateful to Sylvia, is that the pigments, the colorants, they degrade, they lost their colors, they change their colors. And it's very important to know what is the original appearance of the map, of the color. For example, we have a degradation from green to blue, from yellow to white, and all these things. And to explain all these changes, we need, of course, all these instruments. I don't want to go into details here because there are so many instruments, and so there is nothing marked on the instruments. I just want to show that there is a need of more than one tool, and one investigation is non-investigation, in our opinion. However, when we are talking about colorants, we have to think first about what are colorants. What are these materials, the materials which were used as colorants, and we can tell you that everything was used as a colorant. So we have to distinguish between the inorganic pigments and the organic dyes, which is very important because the inorganic pigments are much more stable than the organic dyes, first point. But the second point is also very important. The investigation methods are different. So if you want to analyze an inorganic pigment, you need other instruments than when you want to investigate organic dyes. So pigments, you can see this in the exhibition case in the lobby. Pigments could be natural or mineral pigments, for example, the very nice malachite, which you can see here, or also artificial pigments. And everybody knows the lead white, for example, is one of the most important, oldest artificial pigments. On the other side, you have the organic dyes, which are produced from plants and insects. And there is also in the exhibition case one or two examples, for example, indigo. And of course, we have the artificially produced modern dyes, just indicated with this formula here. Okay, so now just to explain the three columns of non-invasive testing. So that means we have a lot of imaging techniques, and we learned in the morning about multispectral imaging. Was very impressive in the morning, because you can see so many details, but this would be the first step. The second step would be the X-ray fluorescence analysis as an elemental analysis to distinguish between different pigments. And the third step would be chemical or molecular analysis, for example, vibration spectroscopy, FTIR or Raman. That's all to mention for the different techniques. But this is the typical way. You start with the imaging, then the elemental, and then the third one would be the chemical techniques or investigations. So this very nice tiny tool, the so-called Dino light microscope, gives you the first impression. We have a UV light, an infrared with visible light, an near infrared on top of the slide, and you see the different appearance, or that means different absorptions and reflection. And you see, or we see in a minute, that all the black stuff here is a carbon ink, for example, to distinguish the carbon ink from other inks. This is a very nice tool, and it's very easily. We talked about fading, and if you use a UV, for example, you can see exactly iron gall inks, for example, which could fade. So the next one would be the elemental analysis. So this is a huge machine. It's not portable, but transportable. And you see the peaks on the left-hand side, which gives you the X-ray fluorescence peaks from different elements. You see the arsenic, As. You see the copper, Cu, you see calcium, calcite, and you see very quick in a minute which elements are in these pigments. So if you find a copper, you see in a minute, well, it's copper carbonate. It should be a copper green or copper blue. Copper blue means azurite, copper green means, for example, malachite. Or the yellow one, the yellow number 6 here, is an arsenic ore pigment, very toxic and also very fragile. So, but there is also a very last and very easy measurement, the so-called vis spectroscopy. It's just the eye. So it's just an illumination. You take the visible light and illuminate the different colors, and you got these nice reflection curves. And here on the left-hand side, you see two blue pigments, indigo and lapis lazuli, and you see both are blue, but you see the difference. And if you have a appropriate reference database, it's very easy to identify the different blues. So I think that's all to say for the investigation, and I will hand over back to Diana.
Yeah, now we would like to share some of the results we found. So let's start with red colorants on East Asian maps. The signal color red played a very important role in marking larger places on maps, as you can see on these two maps, that extracts of maps that you have seen before. The left-hand side from Korea and on the right-hand side from China. And they were also used, or red was also used for red signs and red framing. It was used for denoting roads or for highlighting details and decorative elements. The predominant red pigment on the maps examined in our studies is clearly cinnabar. So all red elements on these maps on the left-hand side, and here the circles, the squares and so on, they were all colored with cinnabar. Occasionally, we also found red and brown ochre, red lead, and very occasionally we found carmine. This is also a map where you have seen an extract before. Carmine is an organic dye and it is extracted from scale insects. You can see some outside in the exhibition. And you can produce a kind of purple ink, and this purple ink was used on this map to draw the frame around the map title and to draw the grid lines. So this is an interesting map because you have two different grid systems on the same map. The black one is colored in black and the other is colored in red. I could talk for 1 hour just about this topic, but this I want to focus here on the carmine. Due to the widespread color system of the full coloring of the oceans and rivers on East Asian maps, the color blue played, of course, a very important role in tinting these bodies of water. And in addition, blue was mainly used for the coloring of mountain ranges and for graphic and decorative elements. We found indigo on many maps. We found azurite on many maps. Indigo, for example, was used for the rivers and the sea on the map in the middle, a manuscript map from Korea. On the left-hand side, the blue mountains on this map from China were colored with azurite. Occasionally, we also found, very seldom, ultramarine, which is a very expensive colorant, and it was used for decorative elements on maps, like on this map, pictorial map of Wutaishan in China. And you can see these elements were colored with this very bright ultramarine. We also found Prussian blue on East Asian maps. At the beginning of the 18th century, this innovative iron-based pigment was invented in Europe, actually in Berlin. So in German we would say Berlin blue, but the English name is Prussian blue. And it was really amazing how fast this formula, not just the pigment, but also the formula, spread throughout the world, because it was easy and cheap to produce, and how quickly it replaced from the early 18th century onwards the indigo pigment on East Asian maps. So these are maps both from Korea. On the right-hand side, we already know this map, woodblock printed, hand-colored. On the left-hand side, a manuscript map. And we were surprised to find Prussian blue on really early dated Korean maps. So it was really, it just took 2-3 decades to replace indigo completely by Prussian blue on these maps. Yellow colorants on East Asian maps. Yellow played another very important role in map coloring in East Asia. On Korean maps, as you have seen before, the districts of the province in which the capital of nowadays Seoul is located are often shown in these yellow circles. The color was also used for the coloring of signs and cartouches, and the Yellow River was usually colored like its name in yellow. You can see there the Yellow River on the left hand, on the map on the left side. So we found different colorants used for coloring or for coloring red, yellow parts on the maps. First of all, camboge, which is an organic dye. But we also find the highly toxic pigment orpiment that contains arsenic on many maps, in particular from Korea. And occasionally we found yellow ochre, and very occasionally we found gold. On the left-hand side, for example, the Yellow River was colored or drawn with camboge. And these two maps from Korea for the yellow elements we identified ore pigment, so the toxic pigment. After my colleague found out that we found ore pigment on the maps, he suggested that we should rather start wearing gloves because it's toxic. Last but not least, green colorants on East Asian maps. Green was, after blue, very often used to tint bodies of water and mountains. And green colorants, mostly copper-based, so mainly malachite and easy to produce, were often used as green pigments in East Asia. So green was also very often mixed of yellow and blue colorants. On the left-hand side, I think it's really easy to see two different green tones were used. The rivers were colored with malachite, and the sea was colored with an organic dye. Here we have two maps showing Seoul in Korea, part of a map set. The upper part is a woodblock printed map where the green mountains were colored with atasamite. And on the lower map, the colorist used a mix of yellow and blue pigments or colorants to produce the green that was a mix of, again, ore pigment and Prussian blue in this case. And occasionally we found also Paris green, but malachite and mixes of different yellow and green tones were quite common. So these were the maps from the MARKK collection in Hamburg. These were the maps that we examined in our project between 2018 and 21. But I also wanted to share, or we wanted to share, two more maps from or showing parts of Tibet, because this is my field of research now. The first map is very interesting for different reasons. It's a manuscript map that was made by the missionary called just short Mauletti in early 18th century. It is a part of a mission report. It is kept in the Vatican Library. Oliver was so kind. He's quite often visiting this place to do the analysis of the colorants.
The results are unpublished at the moment, so this is the reason we are not so...
So we do not share so much, but this map is very interesting. I'm very interested in hybrid maps, and this is a very nice example for a hybrid map. It was made by a European, but it clearly shows that he was influenced by manuscript maps from China made in the same period. So if you take a look how the places, the cities are represented, you can see the Great Wall. But, and this is really interesting, if we think about the coloring, he throughoutly used local materials. For example, he used indigo to color this is the Kokonor Lake, close to Lanzhou in nowadays Qinghai province in China. So he adopted these local materials to produce this map. And the other map I wanted to share, you can see in the exhibition outside. It is also a hand-drawn map, a manuscript map showing not only Sikkim but also parts of Tibet in the north. And I hope it is easy to see that the lower part of the map was obviously copied from a printed map. A printed map where all the place names were shown the captions in English. The map maker, and I assume it was a Tibetan, he replaced all English place names by Tibetan place names. So the lower part looks quite similar to the printed map with the typical, at least for European maps, the typical border coloring. But what is really fascinating for me, being interested in a hybrid map, is the upper part of the map. So everything, or the area north of the border between Sikkim, nowadays northern India, and nowadays Tibet, China, is shown in a very pictorial, very typical Tibetan map making style, and also for the coloring. So you can see the upper part is completely full colored with a lot of pictorial elements in contrast to the lower parts. And we didn't do any, or no color analysis has been done so far. Oliver's assumption is that...
Well,
Well.
Maybe Paris green, red ochre, and Prussian blue, I think.
We can start
the
betting.
first guess. First guess.
First guess. We
Without
will.
any instruments.
Yeah, exactly. So, as I mentioned before, we only scratched the surface of our research results. If you want to get more information, the book in the middle is open access. This is the exhibition catalog for the exhibition that we organized in Hamburg in the context of this project. That was an exhibition called Color Meet Maps. It's also open access online. The right-hand side, or the book on the right-hand side, is not open access, but it's in your library room. It's available here, so you can read it. And we are now looking forward to questions and comments.
So we can talk about hours about pigments and dyes,
Yes.
of course, but we have to stop now.
Yes.
Thank you so much.
It strikes me that it's quite rare to see a project that's so truly interdisciplinary, where you have two scholars coming to one subject from such disparate fields. And I was wondering if you could talk a little bit about what that was like and what the experience was like of working together.
Well, we have a starting phase, let me say a few months, and to know, to understand how the other disciplines are thinking. So it took a while. What do you think? 3 months or half a year? Because there is a complete different approach. The humanities have complete different tasks and ideas in comparison to the scientific part. It takes a while, and it depends on the people, of course.
Yeah, it definitely took a while. So for me, it was a completely new world. So I entered this world of maps years ago, so I was familiar with maps. And I remember Oliver giving a presentation explaining all the different pigments and dyes in the beginning, and for me nearly everything was new. I mean, I heard of words like cinnabar and maybe also azurite before, but it was fascinating to see Oliver and other colleagues taking a look at the maps before they did any analysis and discussing, this looks like Prussian blue, this looks like, and I was like, what, how can they see it? So I really had to start learning a lot about the different colorants used, and I also started reading painting manuals for Chinese painting to get an idea of what kind of pigments and dyes were used in Asia, because there were of course differences. But it was absolutely fascinating, and for me it was the first project where I really felt like, or how interdisciplinary research can look like, can work like. It's fascinating, really.
Yeah, no, I agree. I think it's, and I think when you see the kind of work that you've been doing together, this is when interdisciplinary work really shines, because it's, yeah.
It is very fruitful. And what is also very important, we have the scientific part, we have the humanities, but we have also the restorers. And they're very, very important also in these projects. And as we learned from the talk from Sylvia, it is so important because the restorers, they know the material, they know the everything about the objects. And so this is always this triangle between these three disciplines.
Yeah, well, I actually have some questions about materials, so I'll dig into those. And I'll combine these two into one. So one question here is, did European and Asian map makers develop the same pigments unknowingly? Like, did we see the same pigments appearing in Europe and Asia? What's the relationship there?
Yeah. In the beginning of this project, we were mainly interested in the differences between the colorants used on East Asian and European maps. And then we were a little bit disappointed because we found a lot of colorants that were used in both regions. But in a way, it's logic, because minerals are found everywhere in the world. So the most important differences we actually found in the use of organic dyes, because they're just different plants and insects available in both regions. So that was the most important difference between two regions. And then it was interesting to see how fast, or how both regions really influenced each other, how the Prussian blue, for example, traveled to the east. And for me it was, for example, fascinating to see I didn't show Japanese maps. We had one Japanese map, and in Japan they produced a white colorant made of shells, but it's islands, it's surrounded by shells, so it's absolutely logic that they used the materials that were available locally.
And we know that there was a lot of trade between Asia and Europe. So this Berlin blue or Prussian blue example, so it was invented in 1704, 1706, and it took 30 years and it became to China. Makes clear that there's a lot of trade, lot of influence on both sides, and this is also reflected in the maps, or in the inks, of course, in the paper, and also on the colorants.
And what about Paris green? What is that made of, and why do we have this name?
Yeah, Paris green. It's the same story as Prussian blue. So you know Paris green as so it's also a very toxic pigment. It contains copper and arsenic, and it was invented in the 19th century. And the names are emerald green, smaragdgrün. What else do we have? So it's a very toxic pigment. But as you can see on the map on the slide, it is a very leuchtend, bright pigment, and so it was used very soon after invention for decoration, for maps. But now it's of course also forbidden because it's really toxic.
Well, when handling maps that have been colored with toxic pigments, what protections do you take?
First of all,
gloves.
Don't lick, don't eat.
Don't
Lick the map.
We were wearing gloves.
Okay.
Yeah. And it was interesting to see in some Chinese color manuals, I found notes, for example, when orpiment was described, notes or warnings for the painters. Please don't lick the instruments because it's toxic.
So it was known that the things are toxic.
Yeah.
This is very important. It's not new knowledge.
Do they become less toxic over time, or is it just?
No, we have the elements, lead or arsenic. They're still on the paper or on the parchment. No, they are toxic. More or less, they become more toxic because due to the degradation, they become more soluble and more vivid, let's say, and so it's more toxic. Mm-hmm.
So you shouldn't do it like in this film, The Name of the Rose film.
Yeah, no.
And what colors would you say then has faded or changed more than others?
Well, as I mentioned before, so the pigments, the inorganic colorants are more stable than the organic dyes. The iron oxide pigments are very stable. Cinnabar is very stable. Also, Prussian blue is very stable. However, orpiment is not very stable because there's a kind of discoloration. It becomes white or beige or whatever. And all the organic dyes, so that means carmine, cochineal, what else do we have? Gamboge, this yellow resin, they lose their color. So the organics are really in danger. And also the green, so the green natural dye, which is very sensitive to light.
Indigo as well. Indigo becomes, I have shown some maps that were colored with indigo, that the sea, they become sometimes a little bit yellowish, greenish, so it's not so stable as the Prussian blue.
And it depends, of course, of the paper or the other supporting material, and how the maps are mounted, for example, and it's a lot of influence on the degradation.
Is still light that is the most dangerous thing to these colors, or is there other factors as well?
I think it's the degradation of paper is also a topic, but I think the discoloration of the dyes is because you lose the original appearance of the map or of the coloration, and so this is worse. So yeah.
Okay, so we just received a question from online, so I'm going to read it out. So when researching the color, are you researching the material base of the color or the effect or reflection of the color regardless of the material? I think the question about is it the elemental properties, or is it the appearance of the color? And I think maybe you are doing a little bit of both with different types of instruments.
Yes, that's right. So yeah, as I told you before, one measurement is non-measurement, or one instrument is non-instrument. So we need more than one approach. Yeah. And it was also very important to say here that we did all these investigations non-invasive, so we didn't take any samples. Of course, this is the next step to do this analysis. We could take samples, for example, for provenance studies of the carmine or something, but we were not allowed to do this.
No.
And it was and it was not necessary to do this, because to find out the colorants, it was done by non-invasive techniques.
We had some of the maps were sent to restaurators before the exhibition, and one of the restaurators in France, she collected some of the pieces that were just falling down, and she sent them to me to Hamburg, and I was really looking forward getting them to be sure or to make other tests, and they never arrived, so it was lost. But this is the only chance to get samples if some things or crumble things during the restoration process. Usually it's not so easy to get samples.
So, Diana, you mentioned at the turn of the 19th century, there was more or less a standard practice for colouring. And what changed at the start of the 19th century to inform or change this?
What changed was the color system. So until mid-19th century, the typical system was to color the sea and to leave the land uncolored. And then, and I'm sure this is influenced by European maps, because on European maps, in particular maps where color was used to distinguish, now I remember the word, distinguish the different political units, like different provinces. The land was full colored, very often in light pink, in light yellow, in light green. These were the typical colors. And from mid-19th century onwards, you find this kind of color system also on Chinese maps and on Korean maps. So you do not find, or in parallel to this cartouches on the Korean maps, the provinces were fully colored. This was, I assume it was an influence of European maps, but that was the change of the color system. Okay. And now all the maps look the same in East Asia and here.
But that's very interesting though. So it's almost that you can see the development, like you can almost see the influence moving through history. Yeah. And through geographical regions.
Yeah, you see, I wouldn't say the development, I would say you see the influences.
Yeah.
Yeah.
Yes, that's I have another question here from online, that some popular Korean atlases, distinguished by the circular world map, are colored rather clumsily, unprofessionally. Are such copies meant for sale, or do you have an explanation for this?
There's a great paper by colleague Vera Dorofiewa-Lichtman on Korean hand atlases. I think she would know the answer. I think a lot of these hand atlases were produced for use and for sale. And many of them are, how to say it nice, colored in not in a very nice way. We have the hand atlas we have in the exhibition. It's beautiful. So somebody really took care to the coloring, but many were just colored with two colors, namely red and blue, in a very fast way, I would say. And I think they were colored for sale.
Is there an indication that this could be done by the early owners of these atlases, or is it done professionally before they're sold?
I think professionally, and it always, like with the coloring of atlases and maps in Europe, it sometimes depended on who commissioned the coloring, how much money was available to pay for a brilliant coloring. I think it was similar there.
What sort of percent, what if you would guess or estimate, what is the percentage of maps that are colored and not colored? Is it a majority or?
I think the majority of printed maps was not colored.
Okay.
In particular, a lot of colors were printed and included in Chinese books, and they were usually not colored. Yeah.
And do we have indication, sorry, I'm just dominating this question there, but do we have indication of how the maps were used from the manuscript annotations or?
For all kind of purposes. Some were made for decorative purposes, some were used for administrative purposes, some were used as visualization for geographical books, all kind of purposes. Military purposes. There are a lot of so-called river maps, in particular China, because river maps were produced to manage rivers, and we have at least two very long rivers, the Yolong-Tsangbo, the Yellow River, that had to be dealt with over centuries. So river maps is a very important genre in China, but also coastal maps. They were used for coastal defense, for military purposes, all kind of purposes.
I think that's all the questions we have, and so I would like us to all thank our speakers again.
Thank you.